This is a task program called Gerwalk Talk Effects. And in this demonstration, I would like to show the effect of setting goal torque and what does it do to the robot and how you can change it by hand, essentially. So this is a leading to later to bilateral control between two robots. Okay, so program start out. First, I want to set up all the slope, margin, and the punch for all actuator. And there are two type of setting here, two type of load command. This one here, if you use a dynamixel option here, you can choose the slope. And normally you have the actual ID. One, two, three, four, five, and all of that stuff up here normally. But if you scroll down enough, you're going to see all. That means all of the 1 through 7 here will be set into a single command, essentially. So that's what it means for. So clockwise slope 32, counterclockwise slope 32, so that's pretty normal. Margin, I said the same way. Address 40 happened to be for the punch, except you can see that under this option, there's nothing for punch. Okay, so the robotics people say, you were not supposed to touch that, I guess, supposed to punch. But punch is at address 48 if you check with the ROM table for all the function for the AX12. And instead of all, 254 is equivalent to it. So this one here is a custom command. You see here, it's under dynamixel, but you go to custom here, address 48 is a word size, and you just type in 254. Okay, so that's the setting. And then next is we set velocity for everybody to 256, so very slow speed. Torque 1023 for everybody, so that means it's pretty stiff. And then everybody go with 512, which is, if you remember, that's the calibration position. So all the leg will be kind of 90 degrees. And then we start the time for about 10 seconds and just essentially do nothing for 10 seconds. And what I want to do is when it's doing that, when we run the program, I'm gonna push on it and you can see that it won't. Right now, there's no power into the bot. So you can see you can manipulate the servo, which all of you, I'm sure, already realize that. And then when it's playing music, that we know when it's ready to do. So during this time here, I want to show that as long as there's power into the servo, you cannot push them. The current will hold in certain position. Basically, it goes in 512. And what I do, although I send the speed to higher speed, 512, I'd reduce all the torque to only about 1. So, and that's the test we're going to do. What happened when all the torque are very small, like 1? And in order to show that, I have an endless loop. I have a variable parameter called 1. I just pronounce 1. And then 36 is essentially present position. And then 40 is a present load. And here also, I want to show you something else. This is ID is a parameter. And normally, you can just go into the dynamixel here. And let's say you want to print out the present position, right? So you choose present position and pick out your ID. Okay. Right here. So present position, and just pick ID 1 or whatever. Okay. However, sometimes you would want it to be variable. So ID here is 1 outside. So this is another way to do it. It's under custom again. And then because address 36 is for the present position, right? You put 36 here, and then it's putting an actual constant. You just put ID, the variable parameter. Okay, that's what's explained that. So let's explain this. The reason is if you happen to be using a loop, like for example, which is coming up, I want to print out all the even servo first, which is essentially the right leg. And then next to it, I want to print out all the servo with the I, which is the left leg. So we have 3 servo on the right leg, 2, 4, and 6. So I'm going to start a variable equal to 2, and then I need to make it change to 4, and then I make it change it to 6. Okay. So that's the reason I have a parameter called even 90. I initialize it at 2, and then something odd, I initialize at 3. And then I create a for loop. So it's going to loop from I equal 1 to 3. So I'm going to make this loop 3 times. So first it print out even ID. So for the first time it goes in, that's going to equal to 2. So it print out custom command again. See here, custom. Put in your parameter after 36. So we'll print out the essentially present position of servo 2 and then the present load of servo 2. And after it's done that, even ID was 2, right? So 2 plus 2 become 4. It reassigns the even ID, so it becomes 4. So the second time we loop around, even ID equals 4. So it will print out the data for servo number 4. And then when it's done, even ID is 4. 4 plus 2 is 6. So it resets even ID to 6. So when it come in here and do the loop for the third time, it will print out the data for servo number 6. Similarly, with the loop 4 here, it's going to print out 3 first, data for 3, and then 3 plus 2 become 5, so I'm going to print out data for 5, and then of course loop around again, do 7, and then I keep on repeating that. And that's kind of the main loop. Essentially, I need to print out one separate because remember, one is, shall we say, they want to shift the body around here. Okay. So let's first check to see if everything is okay. Okay, it should be okay. Oh, you don't see it because it's under your screen. But I'm ready now. Having everything on, turn it on. I would download my COM3. So we would output the program. And here it is. So I'm in play. And I'm going to play. So its first run, you see it's stiff. You see I cannot do it. It's very stiff. You cannot push it down for 10 seconds. Okay, so when you hear the music, it passed the stiff side. So now it starts showing data. You can see it's showing 1, and then you see 2, 2, 4, 6, and then 3, 5, 7. So, but now it passed that stage where it's stiff. So it went torque to 1 now. Torque, go towards 1. See, I can push it down. Okay. And because torque's so weak, it wouldn't even come back. Later, we'll use this effect to our own advantage. Okay. So let me stop that so that we can scroll up here. You can see. Let's see. So 1 at 512. Present load, you see it's already attained that position, so it's 0. Then 2, 4, 6, because they already stopped. So the torque is not very high. So this is kind of when it's already stopped. Let me scroll back up. Let's see. Here we go. So it was around 512. When I push on it, torque roughly 0. And then when I start pushing on some of them, they start reacting and have some torque high sometimes. And here at the end, because first one stay at 0, so it arrives at the position. So the present load you see is 0. 2, 4, 6, close to it, trying to go again. 3, 5, this is way off. It's very far off from 512, so you see it trying to send the torque back, send the signal to go back, but it's the torque limit was to 1, so there's nothing it can do. It's trying to, but there's not enough. Yeah, the current is limited in there. See, you see it's over the limit. You see this silver eye start flashing. That's kind of the situation.